Greetings to dear students. So far we have learned the formula to find the residue of the function f of z at the point a. Okay, so in this video we are going to evaluate or find the residue of a given function at its poles. Okay, so first problem, find the residue of z plus 1 by z square minus 2z at its poles. Okay, so what they are asking to find is to find the residue at its poles. So first let us find out the poles of the given function. So let us take the given function f of z as z plus 1 by z square minus 2z. Okay, since z is common in these two terms, we are taking z outside. So remaining we get z minus 2. So here we have z minus 0 into z minus 2. So here what are the poles? 0 is one pole and 2 is another pole, isn't it? 0 is one pole and 2 is another pole. And 0 is a pole of order what? 1, because z minus 0 of order, it has only is a linear equations of order 1. Similarly, 2 is a pole of order 1. So therefore, 0 and 2 are what? Simple pole. They are simple pole. Okay. So if A is a simple pole, then we have three formulas to find. Okay, so here I have shown all the three methods. I have used all the three formulas to find the residue of the function f of s at the point 0 and 1, 0 and 2. Okay, so in the later problems, I have used only one formulas. In this problem only, I have used the three formulas to show you only. Okay, so first method one, we are going to use the first formula. So what is the definition of okay, note that here we have two poles, okay, 0 and 2. You have to find the residue for 0 as well as for 2. Okay, you have to find the residue for 0 and 2. Okay, because they asked to find the residue at its poles. Okay, so we have to find the residue at the point 0 and we have to find the residue at the point 2. So first we find the residue at the point 0 by using first formula. So residue of f of z at the point 0 is equal to, by definition, limit z tends to a. Here a is 0. So limit z tends to 0, z minus 0 into f of z. So what is the value of f of z? Z plus 1 by z minus 0 into z minus 2. Now z minus 0, z minus 0 will get cancelled. So the remaining we get is limit z tends to 0, z plus 1 by z minus 2. When z tends to 0, this will first numerator term will become 1, the denominator term will become minus 2. So therefore, residue of f of z at the point 0 is minus 1 by 2. Now we are finding the residue of the function f of z at the point 2. By definition, by first formula, limit z tends to 2, z minus 2 into f of z. Okay, remind that. What is the first formula? Limit z tends to residue of f of z at the point a is equal to limit z tends to a, z minus a into f of z. Okay, so this formula only we are applying here. Okay. So residue of f of z at the point 2 is equal to, by the formula of residue, limit z tends to 2, z minus 2 into f of z. Substitute the value of f of z. Z minus 2 and z minus 2 will get cancelled. The remaining term will be z plus 1 by z minus 0. When z tends to 2, the numerator will become 3 and the denominator will become 2. So the residue of f of z at the point 2 is 3 by 2. So we have found the residue at the point 0 and 2 by using formula 1. Now we are going to apply the second formula. Okay, what is the second formula? Residue of f of z at the point a is equal to g of a if f of z is equal to some g of z divided by z minus a. Okay. The second formula, is residue of f of z at the point a is equal to g of a, where f of z is of the form some g of z divided by z minus a. Okay, so first here we are going to find the residue for the point 0. Okay, so residue for the point 0. So wait a minute. Okay, so how we are going to choose the function g of z? I'm going to find the value for this. Okay, so the remaining will become g of z. So then f of z can be written as z plus 1 by z minus 2 divided by z minus 0. So this term will become g of z. Okay. So by okay. So this is what I have written here. Where g of z is equal to z plus 1 by z minus 2. Okay. By the residue formula is residue of f of z at the point 0 is g of 0. So substitute 0 in g of z, we get 1 minus 1 by 2. Similarly, when we find the residue for the function f of at the point 2, g of z becomes, yeah, okay. G of z becomes z plus 1 by z. Okay, z plus 1 by z divided by z minus 2. So this is what our g of z. So residue of f of z at the point 2 is equal to g of 2. So substitute, replace z by 2, we get g of 2 is equal to 3 by 2. Okay, so this is easier than this second method is easier than the first method. Okay, so now we are going to apply the third formula. So what is third formula? Residue of f of z at the point a is equal to h of a by k dash of a, provided h of a and k of a are nullity at a and h of a not equal to 0 and k of a equal to 0. So here the first pole is 0. So therefore residue of f of z at 0 is equal to, by definition, the third formula, h of 0 by k dash of 0, where h of z is equal to what? The terms in the numerator part. Okay. When we going to, okay, terms in the, wait a minute. Okay, the terms in the numerator part. Okay, the terms in the numerator part is h of z. The terms in the denominator part is k of z. Okay, here you don't need to separate z plus 1 in, into numerator something. Okay, here we don't, because f of z in the lemma, the statement is f of z is of the form some h of z by k of z. Okay, and not particularly some z minus a. So whatever it is in the numerator, you can take it as h of z, and whatever it is in the denominator part, you can take it as k of z. Okay, yeah. So yeah, h of z is equal to numerator, k of z is equal to denominator. Next we are checking h of 0 should not be equal to 0 and k of 0 must be 0. H of 0 is clearly 1 not equal to 0 and k of 0 is clearly 0. So by the residue formula, residue is equal to h of 0 by k dash of 0. So here I need to find the k dash of z, so that only I can substitute 0 in that k dash of z. So k of z is z square minus 2z. So then what is the value of k dash of z? 2z minus 2, which from this k dash of 0 is equal to minus 2. So therefore residue of f of z at 0 is equal to h of 0. What is the value of h of 0? 1. What is the value of k dash of 0? Minus 2. So therefore minus 1 by 2. Similarly, residue of f of z at the point 2 is equal to h of 2 by k dash of 2, where h of z equal to z plus 1 and k of z is equal to z square minus 2 minus 2 z. We have to check h of 2 must not should not be equal to 0 and k of 2 should be equal to 0. So h of 2 is equal to 3 not equal to 0, k of 2 is equal to 0. So it satisfies the given condition. So therefore, residue of f of z at the point 2 is equal to h of 2 by k dash of 2. The value of, so here we need to find the find k dash of z. So what is k dash of z? 2 z minus 2. So from this, k dash of 2 is nothing but 2 into 2, 4 minus 2 is equal to 2. So now we have found find the value of h of 2 and k dash of 2. Substitute this, we get residue of f of z at the point, sorry, it is not 0, it is 2. Okay, residue of f of z at the point 2 is 3 by 2. Okay, so in all these three formula we have found the residue at the point 0 and 2. Okay, so whatever whichever formula you are comfortable with, you can use this, you can use that one. If you ask me, then I will choose the second method because it is very easy to compute. Here in the third one we have to find the differentiate part. Okay, but here in the second method it is no need, there is no need to find the differentiation. Okay, and note that in some places we cannot apply first method and second, I mean first formula and second formula. Suppose if the function f of z is equal to some cos z or sin z, which is equal to yeah, cot z. Cot z can be written as cos z by sin z, isn't it? So sin z is not in the form some z minus a. So you cannot apply method 2, the formula 2 and formula 1. In that particular case, you have to go with the formula 3. Okay, so if formula 2 is you can apply formula 2 for the particular function, means you can go with the formula 2. Otherwise, if you can't apply, okay, if you can't apply method formula 2, means you go with method 3 or formula 3. Okay, so you choose wisely according to the given problem. Okay, so thank you, dear students. In the upcoming videos we will see the remaining problems. Okay, so thank you.